All right, day 2 of normal distributions, non-standard normal distributions. So non-standard means it's not going to be with a z anymore, now it's with x, and that just means that we have a different mean and a different standard deviation. The mean is not 0 and the standard deviation is not 1. So let's look at the graph, and we're trying to find out the z-score corresponding to 5.5. So let's look at the mean is 5 and the standard deviation is 0.5. So we go up 0.5, we go down 0.5, we can go up 0.5 again, that would be a 6, and that would be a 4. We're moving by standard deviations of 0.5. We know that these are x values, so the z values, this would be z is 0, z is 1, z is 2, -1 and -2. This leads to a formula to convert x values to z values. So if we were looking, we wanted to find that, we'd know that z is equal to x minus the mean over sigma. Z is equal to x minus the mean over sigma. So we get 0.5 over 0.5 and we get 1. This formula allows us to convert from x values to z values, which is necessary if we're not just counting by, this was easy because we're counting by standard deviations, but if that was 5.7, if I had some value of 5.7 that I had to convert, it wouldn't be as easy to just match them up like that. Okay, so now that we have converted, we could say that the probability of x being between 4.5 and 5.5 is the same as the probability of z being between -1 and 1. So that simplifies to a problem that we can do without a calculator because we know by the empirical rule that one standard deviation up and down has an area of 0.68, a probability of 0.68. We can also, without doing any of this work, we can just type this into the calculator, enter the mean and the standard deviation, and it would give us a more accurate number than that. Pause the video, try this problem, and make sure you draw the graph. So we know the mean is 10 and standard deviation is 2. We could go up 1 standard deviation, we could go down 1 standard deviation. If these are x values, then the z values, since we're moving 1 standard deviation, we know those are the z values. So here, since we're moving 1 standard deviation, we know that 8 corresponds to z equals -1, but we can also use the formula, and that's going to be x minus the mean over sigma. We get -2 over 2. The probability that x is between 8 and 10 is the same as the probability that z is between -1 and 1. Oops, that's 0. So 10 corresponds to 0. the probability that z is between -1 and 0 is going to be this area, which is half of 0.68, and that means we have 0.34. The mean is 50, standard deviation is 5. What z-score corresponds to 57. Find the probability that x is greater than 57. Oh, we start with a graph. The mean is 50, standard deviation is 5, so 55 and 45, those are x values. We know the z values are these. But we're looking at 57, and if we went up another standard deviation, it would be at 60. So we know that this is not z equals 1 or 2, it's going to be some decimal. So to do that, we would use the formula z equals x minus the mean over sigma. The x value that we want is 57, minus the mean is 50, over sigma is 5, 7 over 5, and we get 1 2/5, or 1.4. Z is 1.4. So if we were using a z table, we would say x greater than 57 is the same as probability of z greater than 1.4. So to answer this question, it said what z-score corresponds. So we did answer that question. But with a calculator, we can just type this in. Let's do that. So to do this, we have normal CDF, and then it's going to be the boundaries. It's going to be x greater than 57. So if we have 57 here, we want to go greater than that. It's going to be 57 up to 1,000, or 10,000 or a million, whatever you want to put there, with the mean of 50, standard deviation of 5. So if you do this in the calculator, we should get 0.0808. If you did this in the calculator with a mean of 0 and standard deviation of 1, you would also get 0.0808. All right, pause the video and try that one. Mean is 60. One standard deviation up is 67. One standard deviation down is 53. We're going plus 7, minus 7. We're looking for 62 to 64. So that's within 60 and 67. We're looking for 62 to 64, somewhere in there. And we have z at 64 is going to be 64 minus 60 over 7. And we get 4 over 7. Z for the x value of 62 is 62 minus 60 over 7. We get 2 over 7. We can find this probability using z-values or x-values with the calculator. If we use the x-values, we'll have normal CDF, and it's going to go from 62 to 64 with a mean of 60, standard deviation of 7, and we'll get 0.1037. All right, for the next problem, let's review that the probability of A given B is equal to the probability of A intersect B over the probability of B. So we need to use that formula for conditional probability in the next problem. Test scores are normally distributed with a mean of 85 and a standard deviation of 8. Find the probability that x is greater than 90. Find the probability that x is greater than 90 given x is greater than 80. Find the probability that x is less than 70 given x is less than 80. 3 questions here. X greater than 90, the score is greater than 90, or if you know the scores are greater than 80, what's the probability of being greater than 90? Out of all the scores that are less than 80, what's the probability of being less than 70? All right, so the first one, the probability that x is greater than 90, let's draw the graph for that. And the mean is 85. We're going to go up to 90, and we want to know the probability of being greater than 90. So check that on the calculator. Math. Second vars, normal CDF. Left bound is 90. Upper bound, some big number. The mean is 85. Standard deviation is 8. 0.266. 0.266. All right. The probability that x is greater than 90 given x is greater than 80 is the probability that x is greater than 90 and x is greater than 80 divided by the probability that x is greater than 80. So this, I think, can be a little confusing the first time you see it. The intersection of greater than 90 and greater than 80. So if we look at a number line and we know that it's greater than 80 and we want it to be greater than 90. So the intersection of this is just greater than 90. It's the same as saying x greater than 90 divided by the probability that x is greater than 80. All right, and we already know that that's 0.266. Let's not round it yet. And then this is going to be 0.73401. So we should have 0.3642. Alright, pause the video and you try this one. The probability that x is less than 70 and x is less than 80 divided by the probability that x is less than 80. Let's think of how to simplify that. If we have a number line and we're going from 80, we want less than 80, so that's going to go that way. We want less than 70, and that goes that way. So it's the same as saying, if we want the intersection of both of these, it's the same as x is less than 70. X less than 70 divided by x less than 80. Probability of x less than 80. So here we have 0.0304 over 0.26599, and we get 0.1143. All right, and there's only one more concept we need to know, and that is inverse norm. Now, we know the probability, so we have to use inverse norm to find k. This is a pretty simple one. They do get more complicated on the IB test, but for now, just to get the concept, let's look at this. And also, the graph can really help a lot with these types of questions. And x is less than k is a number less than a half. So, should k be on the left or should k be on the right? So that's an important consideration. We know that we should be shading x less than k, we should be shading to the left of k. So which one of these graphs looks like it could have an area of 0.13? We know that this has to be greater than 0.5. This is like 0.8 maybe. 0.13 could be this area. Okay. All right, so we know it has to be this one. And that means we need to do in the calculator, we use inverse norm, and it's going to be the probability, and then we can give it the mean and the standard deviation. So that gives 9.437. K equals 9.437. This can be a little tricky because this requires area to left. If we were given an area to the right, we would have to find the complement of that to enter into this. So inverse norm will only calculate the x value if this area is to the left. So think about that and see if you can figure this one out. Pause the video and try this one. So, is k on the left or is k on the right? We know that we're shading to the right, and it's 0.32. So if I'm shading to the right, that doesn't look like 0.32. It's bigger than 0.5. And here, this could be 0.32. So we know that k is going to be over here. But also, we know that this is 0.32, and to use inverse norm, we should be looking at 0.68. It doesn't matter whether I'm talking about 0.68 to the left or 0.32 to the right, it's still going to be the same number here. This number divides the graph into these two areas. So then we can just do inverse norm, and it's going to be the probability, the mean, and the standard deviation. .5047. And does that seem reasonable? Well, look at the mean is 0.5, and the standard deviation is very small, so we're just moving over a small distance, and that is reasonable. And we'll stop there.